Good morning. Here's your daily tech briefing for 2026-08-11. Today we're covering Spring Boot, Apache Kafka, Redis, Docker, Kubernetes, Git, and Cloud, AWS/Azure/GCP, plus the Architect's Corner. Let's get into it. If you're a developer working with Spring Boot, you're likely familiar with the process of starting and stopping your application, checking logs, and configuring settings. However, navigating through the various endpoints and configurations can be cumbersome, especially for complex applications. That's where Developer UI can come in handy, providing a centralized interface to manage and monitor your application. Recently, a project on GitHub caught attention, aiming to fill this gap for Spring Boot and Quarkus applications. The project, called Boot UI, is an open-source developer UI designed to simplify the development process. By providing a user-friendly interface, Boot UI allows developers to easily access and manage various aspects of their application, such as environment variables, logging levels, and HTTP endpoints. The creator of the project, Jay Dubois, has made the code available on GitHub, where it has been shared on platforms like Hacker News. Although the project has only garnered a couple of points and no comments so far, it has the potential to make a significant impact on the development workflow of Spring Boot and Quarkus applications. For developers working with these frameworks, a tool like Boot UI could save time and reduce frustration by consolidating key application management tasks into a single, intuitive interface. By streamlining the development process, Boot UI could improve overall productivity and efficiency. As the project evolves, it will be interesting to see how the community responds and contributes to its development. With its promise of simplifying Spring Boot and Quarkus development, Boot UI is definitely worth keeping an eye on for developers working with these popular frameworks. Apache Kafka is an open-source event streaming platform used for high-throughput and scalable data processing, and it's a crucial tool for many backend and DevOps engineers. Recently, an article on Southwest Review.com caught our attention, titled How to Read Kafka, not about reading the famous author Franz Kafka, but rather about understanding and working with the Apache Kafka platform. The article provides 3 key points for engineers to get started with reading data from Kafka. First, it emphasizes the importance of understanding Kafka's core concepts, such as topics, partitions, and brokers. This foundation is crucial for designing and implementing efficient data processing pipelines. For instance, knowing how to properly partition data in Kafka can significantly impact the performance and scalability of your application. The second point highlights the need to choose the right Kafka consumer configuration for your specific use case. This includes settings such as batch size, fetch size, and auto-offset reset. These configurations can greatly affect the throughput and latency of your data processing pipeline. For example, setting the right batch size can help optimize the performance of your Kafka consumer, while an incorrect setting can lead to performance issues or even data loss. The third point discusses the importance of handling errors and exceptions when reading data from Kafka. This includes implementing retry mechanisms, handling offset management, and monitoring consumer performance. By properly handling errors and exceptions, engineers can ensure that their Kafka-based data processing pipelines are reliable and fault-tolerant. Many companies, such as LinkedIn, Uber, and Netflix, rely heavily on Kafka for their data processing needs, and understanding how to read and process data from Kafka is essential for building scalable and efficient data pipelines. Let's dive into some Redis news. For those who might not be familiar, Redis is an in-memory data store that can be used as a database, message broker, and more. It's known for its high performance and flexibility. Recently, a new Redis SDK called Redora has been released for Nest.js, a popular JavaScript framework for building server-side applications. Redora is designed to make it easier for Nest.js developers to interact with Redis, providing a simple and intuitive API for common Redis operations. This can be particularly useful for building high-performance applications that require low-latency data access, such as real-time analytics, gaming, or live updates. By using Redora, developers can focus on building their application logic without worrying about the underlying Redis implementation details. the release of Redora is significant because it fills a gap in the Nest.js ecosystem, where developers previously had to use generic Redis clients or build their own custom integrations. With Redora, developers can now take advantage of Redis capabilities, such as pub/sub messaging, transactions, and pipelining, directly within their Nest.js applications. This can lead to improved application performance, scalability, and reliability. Although the announcement of Redora on Hacker News didn't generate much discussion, with only 2 points and 0 comments, it's still an important development for the Nest.js community. As more developers start using Redora, we can expect to see more feedback and contributions to the project, which can help improve its stability and feature set. Overall, Redora has the potential to simplify Redis integration for Nest.js developers and enable them to build more robust and scalable applications. Docker has been a cornerstone of modern software development and deployment for many years, allowing developers to package, ship, and run applications in containers. Recently, an article on Fagnerbrack's blog took a step back to examine what Docker is and what it has quietly replaced in the development workflow. The article highlights how Docker has become an essential tool for developers, providing a consistent and reliable way to deploy applications across different environments. It's interesting to note that Docker has replaced several traditional methods of deployment, such as manually configuring servers and using virtual machines. By providing a lightweight and portable way to deploy applications, Docker has made it easier for developers to focus on writing code rather than worrying about the underlying infrastructure. In other Docker-related news, the company has announced a new product called Docker Sandboxes, which provides disposable, isolated sandboxes for AI agents. This new product is designed to make it easier for developers to test and train AI models in a secure and isolated environment. Docker Sandboxes uses the same containerization technology that powers Docker, but applies it to AI workloads, allowing developers to spin up and down sandbox environments as needed. This can be particularly useful for data scientists and machine learning engineers who need to test and train AI models on large datasets. With Docker Sandboxes, they can create isolated environments for each model, ensuring that they don't interfere with each other and that sensitive data is kept secure. The announcement of Docker Sandboxes has generated a lot of interest in the developer community, with over 600 points and 350 comments on Hacker News. For developers who are already using Docker, it's worth noting that the concepts and workflows they're familiar with are being adopted by other platforms. For example, Vercel, a platform for building and deploying web applications, has published a guide on how Docker Compose concepts map to their platform. This guide is designed to help developers who are already using Docker Compose to deploy their applications to Vercel, and provides a detailed overview of how the two platforms align. By understanding how Docker Compose concepts map to Vercel, developers can more easily deploy their applications to the platform and take advantage of Vercel's features such as serverless functions and edge networking. This is a great example of how Docker has become a de facto standard for containerization, and how other platforms are building on top of the workflows and concepts that Docker has established. The fact that Vercel is supporting Docker Compose concepts is a testament to the popularity and widespread adoption of Docker in the development community. It's also a recognition that many developers are already using Docker to deploy their applications, and that providing support for Docker Compose can make it easier for them to adopt the Vercel platform. By providing a guide on how Docker Compose concepts map to Vercel, the company is making it easier for developers to get started with the platform and to take advantage of its features and capabilities. Overall, the news from Docker and its ecosystem is a reminder of the importance of containerization in modern software development, and the many ways in which Docker is being used to simplify and streamline the development process. Whether it's providing disposable sandboxes for AI agents or supporting Docker Compose concepts on other platforms, Docker continues to be a vital part of the development workflow. Kubernetes has been a focal point of interest in the developer community, with various approaches to enhance its security and automation. Recently, an article on Medium highlighted the importance of Kyverno policies in securing Kubernetes clusters. Kyverno, for those who might not be familiar, is a policy engine designed specifically for Kubernetes, allowing users to define and manage policies that enforce security, compliance, and operational best practices within their clusters. The article outlines 5 specific Kyverno policies that can significantly bolster the security of a Kubernetes cluster. These policies range from ensuring that all pods have a security context defined, to enforcing the use of trusted container registries, and even implementing network policies to restrict unnecessary communication between pods. By implementing these policies, Kubernetes administrators can proactively mitigate common security risks and ensure their clusters are more secure and compliant with organizational standards. In another development, a blog post on LangChain discussed the creation of an autonomous site reliability engineering, or SRE, agent for Kubernetes deployments. SRE is a set of practices that aims to improve the reliability and performance of systems by applying engineering principles to operations work. The idea of an autonomous SRE agent is to automate many of the routine and complex tasks associated with managing Kubernetes deployments, such as monitoring, troubleshooting, and optimizing performance. This autonomous agent utilizes AI and machine learning to analyze the state of Kubernetes deployments and make decisions to improve their reliability and efficiency. The agent can automatically detect issues, propose fixes, and even implement changes to ensure deployments are running smoothly. This level of automation can significantly reduce the workload of SRE teams and improve the overall resilience of Kubernetes-based systems. Companies and projects looking to streamline their Kubernetes operations could benefit from exploring such autonomous SRE solutions as they continue to evolve and mature. GitHub has just announced the availability of the GitHub Copilot SDK for Java, which is a significant development for enterprise Java developers. This SDK allows developers to harness the power of GitHub Copilot, a tool that provides AI-powered code suggestions directly from their Java code. What's interesting here is that the SDK is designed to work seamlessly with idiomatic Java code, which means developers can use familiar Java annotations and other language features to drive Copilot. For those who may not be familiar, GitHub Copilot is essentially an AI pair programmer that can help with code completion, suggesting entire lines or even blocks of code based on the context of the project. The introduction of the SDK for Java means that developers can now integrate this functionality into their existing Java workflows, potentially streamlining their development process and reducing the time spent on writing boilerplate code. The use of virtual threads in the SDK is also noteworthy, as it allows for more efficient and lightweight execution of Copilot suggestions. This is particularly relevant for large-scale enterprise applications where performance and scalability are crucial. By leveraging the GitHub Copilot SDK for Java, developers can tap into the capabilities of AI-powered code generation while still working within the familiar confines of the Java ecosystem. Companies and projects that heavily rely on Java for their development will likely be interested in exploring this new SDK and how it can enhance their development workflows. In the world of cloud computing, several developments have caught our attention over the past 24 hours. First, let's look at Amazon Web Services, or Oz. The company recently hosted its AWS Heroes Summit, an annual gathering that brings together experts from around the world who specialize in areas like artificial intelligence, serverless computing, and containers. This invite-only event provides a platform for these global experts to collaborate, dive deep into technical topics, and share feedback. The summit is a significant event for the AWS community, as it allows the company to recognize and reward the contributions of its most dedicated and innovative users. By fostering a sense of community and encouraging collaboration, AWS aims to drive innovation and push the boundaries of what's possible on its platform. Meanwhile, over at Google Cloud Platform, or GCP, there's been an update to BigQuery, the company's fully managed enterprise data warehouse service. Specifically, BigQuery now supports 2 new generative AI models, known as Gemini 3.1 Flashlight and Gemini 3.5 Flash. These models are available for use in the US, EU, and global multi-regional endpoints, and can be used with all generative AI functions. This update is significant because it gives BigQuery users access to more advanced AI capabilities, which can be used to analyze and generate insights from large datasets. By supporting these new models, Google Cloud is making it easier for developers to build sophisticated AI-powered applications on its platform. For those looking to take advantage of these new models, Google Cloud provides documentation on how to specify a multi-regional endpoint and how endpoints are selected, which can be found in the Generative AI Overview section of the BigQuery documentation. Now, let's shift gears for the Architect's Corner. 5 minutes on real enterprise software architecture and system design. The Amazon Builders Library is a treasure trove of system design knowledge, offering a unique glimpse into the architecture and design decisions behind some of Amazon's most critical systems. One of the key challenges that Amazon's engineering team faced was building a scalable and highly available e-commerce platform that could handle massive traffic and transaction volumes. As the company grew, its platform needed to evolve to support increasing demand, ensure low latency, and provide a seamless user experience. At the heart of this challenge was the need to design a system that could efficiently manage a large number of concurrent requests, process transactions in real time, and handle failures without impacting the overall system availability. The team realized that a traditional monolithic architecture would not be able to scale to meet these demands, and therefore, they decided to adopt a microservices-based approach. This involved breaking down the platform into smaller, independent services, each responsible for a specific function, such as order management, payment processing, or inventory management. The solution that Amazon's team built was a service-oriented architecture, where each microservice was designed to be highly scalable, fault-tolerant, and loosely coupled. This allowed the team to develop, deploy, and manage each service independently, without affecting the overall system. The use of APIs and messaging queues enabled seamless communication between services, ensuring that data was consistently propagated across the system. Additionally, the team implemented a number of other design patterns, such as load balancing, caching, and content delivery networks, to further improve the system's performance and availability. What's interesting about Amazon's approach is the emphasis on designing for failure. The team recognized that in a complex system, failures are inevitable, and therefore, they built mechanisms to detect and recover from failures quickly. This included implementing circuits breakers, which prevent a failed service from bringing down the entire system, and using automated rollback mechanisms to quickly restore the system to a previous stable state. So, why does this matter for enterprise software architects? Firstly, it highlights the importance of designing systems that are scalable, fault-tolerant, and highly available. As systems grow in complexity, it's essential to adopt architectures that can handle increasing traffic and transaction volumes while ensuring low latency and high availability. Secondly, it demonstrates the value of a microservices-based approach, where smaller, independent services can be developed, deployed, and managed independently, allowing for greater agility and flexibility. Finally, it emphasizes the need to design for failure, recognizing that failures are inevitable in complex systems and building mechanisms to detect and recover from failures quickly. The Amazon Builders Library provides a wealth of information on system design and architecture, offering practical insights and lessons learned from Amazon's own experiences. For enterprise software architects, this resource is invaluable, providing a unique glimpse into the design decisions and trade-offs that have shaped some of the world's most scalable and highly available systems. By studying these examples and applying the principles and patterns described, architects can build their own systems that are better equipped to handle the demands of modern enterprise software development. In terms of takeaways, one key lesson is the importance of loose coupling and high cohesion in system design. By breaking down a system into smaller, independent services, architects can create systems that are more modular, flexible, and scalable. Another key lesson is the need to prioritize fault tolerance and availability, recognizing that failures are inevitable in complex systems, and building mechanisms to detect and recover from failures quickly. By applying these principles and patterns, architects can build systems that are better equipped to handle the demands of modern enterprise software development and provide a foundation for long-term scalability, reliability, and success. Ultimately, the Amazon Builders Library is a must-read for any enterprise software architect looking to build scalable, highly available, and fault-tolerant systems. The lessons and insights provided offer a unique glimpse into the design decisions and trade-offs that have shaped some of the world's most successful systems, and provide a valuable resource for architects looking to build their own systems that can meet the demands of modern enterprise software development. And that's your briefing for today. See you tomorrow morning.